Welcome to Online Game Freaks. This is Freaks. Thank you for joining our ongoing series to take on the hardest raid in Scrap Mechanic, a tier 10 raid, which takes 100 crops and the highest tier vegetables and fruits that you can plant. And to prepare for that raid, we are building a fully automated planting and watering system. And in this episode, we'll be covering the final edition of our watering system that you see here, complete with a computerized driven system that keeps track of each row, and we'll show you how all of this works throughout the video. But today, our focus will be on the watering system and completing this setup and getting it prepared to add on the additional components of both the automatic seeding system and harvesting system. So this sets up the foundation for us to put that full system together, and will be fully automated. So without much further ado, let's start at the beginning and show you how this all came together. Let's go ahead and expand this into the new model, into our new space. And for that, I have this beautiful iron wall for us to begin the whole process of establishing the new watering system. And what we're going to do is basically teach it to count. We're going to set up a binary counting system using the logic gates. And so, well, step one, we're going to start switch. And just so we can do some testing, and we'll have the ability to advance our row count, we'll install this here. Okay, so we've got our switch, we've got our button. Next up, well, let's go ahead and create our 1-bit generator, and we're just gonna separate it this way. It's the easiest way I know, just to keep the logic straight in my head. And we want to start with our XOR gate, and up here we're gonna put a NOR gate, and the bottom can stay an AND. And the wiring on this is very particular. You have to make sure you go from this one, make sure you're going from the XOR gate into both of the other two, and then go from the NOR gate into the AND gate. And then you put the button in into the first one, or the switch, which is fine. So now when I hit the button, we get that blip, that nice single blip here in the AND gate. Next up, we're gonna go ahead and establish the memory. So let's stack up some of those. So our first memory bit we'll put right here, 1, 2, 3, and we make these all XOR gates. Very important. Doesn't work if they are AND gates. And it doesn't work. There we go. So now what we have is, when we get this 1-bit blip, we go into all 3 of these at the same time. And that is like our first binary memory bit. It just turns it on and off. And that will become actually our first 2 rows in the garden. We're going to focus on just setting the memory. We're teaching it to count. So right now I can count to 2. So we're going to double that when we connect these as well to create our memory bit. Don't forget to make them XOR gates. All right, and they're all connected, so we have a memory bit. And to activate this, we want it to activate when the prior conditions have been met. So when it has to have already counted through this first binary piece. So when this goes from its normal begin state, which is off, its second state, which is on, or we'll call it 1 to 2, right? It's now counted to 2. And now that it's at 2, and only when it's also on at 2 and it gets another click, do we want it to turn on this second memory bit. And you got to do them all 3 at once or it gets out of whack. So now if I click it, you'll see it's now moved to a third number, or a third binary position. So it's gone from 0 to 1, and now it's gone, or you could call it, I'll probably screw this up. You're welcome to correct me. It's gone from a 0, 0 position into a 0, 1 position. All right. So this position goes from 0 to 1, and this position can go from 0 to 1. And basically, a 0 plus a 1 is a 3. But the way we're going to use it anyway. And by doing that, we do the next click, and now we have 4. Both on equals 4. But if we click it again, everything turns off. And we got more rows than that. We want it to count to at least 5. So we're going to have to add 1 more memory bit, like so, and do the standard wiring. It needs to be an XOR gate, XOR gate, XOR gate. and we wire them all together. So we have a nice memory chip. And it very similar to the other one, we got rules. It says we don't want to fire this memory bit unless we fully count it up. And the way to do that is, of course, we're going to add another condition here. It says, okay, so now I need to make sure that not only is, there's the wiring tool. I need to make sure I get a blip, of course, but now I also need to make sure that these are on, both of these are on, and I get a new blip. So I'm going to say, okay, both of these are on and I get a new blip, then turn on my memory. Let's test it. We're at 0 or 1, depending on how you want to count it, but we're all off. That's we'll call it 2 here. We'll call off 1. So this is 1, 2, 3, 4, 5. It counts to 5. However, the challenge is now it's going to keep counting. 6, 7, 8, and then it starts over. So now we've done binary up to 8. It just doubles. That's how binary works. So we've gone from a 0 or 1 to a possible 4 to a possible 8 positions. So now what we're going to do in the field is I want the harvesters to, we're going to run 2, and we're going to run them in 5s. So I want it to go to 5, and then I want it to stop and go all the way back to the beginning and repeat. And over here, I want another 5. So they'll run together. They'll be tied together similar to how I showed you before. But I'll be able to separate the crops in the 2 if I want. Like to say one is always going to run potatoes and the other is going to run oranges, for example. So we have that ability. So what I want it to do is count to 5, and then I want it to stop and reset. So the condition for that is we're going to build a little memory bit here that's going to say, okay, in the condition that we've got our 5 count going, let me just move it to that position, like so. So now we're sitting here, and if I get another blip, which, always starts with that, okay, we've got another click, what do I do? And in this case, we want it to establish, it says if you've counted to 5, reset this, and also don't do the blip you did here. And there may be a better way, but this way it only takes a second, and if as far as like moving the carriage around, you get a little tiny click here, but it goes away immediately, and it turns out to not be a big deal. So, but basically, if you get another click and these lights are on, turn them off and reset everything back down to 0. So what I did is I'll put down another, because I wanted to do it in step. So at first check, logic check is this light's on and I get another click. If that's true, then I want you to execute this command, which is to turn that memory bit off. And when you click it, it's going to set this memory on for a second, and we're just going to turn that off. There may be, again, a more elegant way to do this, but this works, and I can already think in my brain's trying to think of other logic ways to do this. I know it's spaghetti, but basically this should be a way of making it count to 5 and then reset. We'll test it. So we're now sounding at 5, and what it should do is it'll get a blip through the system. It should go through this system and say, the blip will come through and turn this on, and just for a second, because it will quickly see that it has these on, and then it'll say, nope, turn those off, and then turn these back off again, and the system will be set back down to 0. So let's test it. Look, there it is. It went all the way back down to 0. So now if we test it, it counts to 5. So we start here with everything off. 1, 2, 3, 4, 5, and it resets. And now we've got a system that counts to 5. We've got 10 rows, so we can do 2 rows of 5. And the math should work out perfectly. And the way that we're going to make this counting system work is we're going to tie it to these pistons. Now, one thing we can do is, the easy answer is we've got this controller for moving these back 2 pistons that just need to go the full length. They're full 15, and maybe the second one will cut a little short. And we'll build it into our system. It's a cosmetic thing, but I'd like to get it right. Oh, I like to see the doodads. There's a side that has buttons. There we go. Okay. And this is simply an on-off thing. So when we turn this on, Let me make sure the system's off here. Let's turn it off. So now we got the controller set, and we're gonna, I wonder if I can reach. There's one. Oh, nope. Controller. Can I reach? Oh, it won't let me reach. I'm gonna do a little jogging. So we've got the 4. So when we first fire off, we need these 2 to go full length, nice and slow, and then these 2 to go full length, and that's it. So let's just test this, just to see, test as you go. Otherwise, you're just going to program in problems, and it's pretty good. Yeah, let's see. It's going to probably go a little long. Yeah, it's just yeah, we'll make these 13s. And perfect. Even the sled lines up. So next up, the next up is an interesting way, because we're going to build it into a system of firing pistons that when they total, they'll cover the 5 crop plots that they need to. And it's basically coming up with a combinations that equal 3, 6, 9, 12, and 15. And we'll be able to do this with a few pistons that'll get us there. We'll see if it won't quite take 2, because you're kind of doing them in magic combinations, or they're mathematical calculations if you'd rather, but it's more fun to call it magic. But what we're going to be able to do is just by firing, well, like say one piston is going to be at 3, and the next one will be at 6. And between them, we can fire the one piston, will take us over 3. We can fire the second piston only, which will take us over to the 6. But if we fire both, it'll take us over to the 9. And if we add another piston, you get more combinations. It's very similar to actually how it's set up exactly to work with the memory bits that we've set up. So when these lights are on in their various positions, it will fire off the pistons to show how we want those to work. So the only catch here, and you can see I was very careful, I'm not attaching any of this to the building, is we're going to do a little monkeying around with the pistons, and we may need to do some welding, and we're just going to put it right back where it is now. Exactly that, right? So now this one needs to be a 3. This one is our 6. This one is our 12. And it's the magic combination of these that's going to equal the crops down below. Excellent. So we've got a little wiring to do, of course, to make that happen, but we've got this. So we really want the first one, the 3, this little guy. He's going to go when this first chain is on. And the second one is going to fire when the second guy is on. Ugh. Navigating. Okay, so that's a 3 and that's a 6. And when they're both on, it'll go to a 9, which is exactly what we want. That's a 3, a 6, and then a 9. We'll start at 0, then I go 3, then I go 6, then they'll both be on as a 9, and then they'll switch over to the next one, which is our 12. And when this 12 is on, is when we want the 12 to fire, like so. I've done a little fiddling with the system, and after making a few adjustments, I think we've settled on something that's very workable. I know it looks like spaghetti, and programmers have spaghetti code, and I think this is probably the same thing. I'm sure there's a more efficient way to do this. However, this system seems to be working. And the solution I have for it is to work in 2 systems. So when the switch is thrown, it begins, of course, activating the process for the memory to be working, but it's not necessarily attached to it, because it can be in any position, and when you start the on switch, it'll start planting from that position. So we have a nice manual button. I'm going to keep this. I like it. Nice fun way to adjust where we're planting at. And then when we throw the switch, the controller just slowly takes it out and then brings it back in. We'll loop it, and it goes back and forth. But as it does so, it's going to have these sensors up here. And when it goes out to the end, this sensor will click it over and it will click the memory on and it'll move over a row. So I turn it on. It just makes its merry little way. It pauses at the half point and then it continues until it gets to the end. The memory was triggered there when it got to the end by the sensor, and now it's really waiting on the controller programming. I have it just to hold the pause. I want to make sure it has plenty of time to move over. This isn't something that we need to be fast, and it brings it back nice and slow. Let's hook up some water and see what kind of coverage. That'll be, it'll help us test out any other fine tuning as necessary. And oh, yep. Yeah, I'm like, because we don't have, I see the sensor here. I'm like, oh, that should be hooked up. But that's exactly what we're doing now, is we're trying to hook up these sensors. Okay, so one thing I already want to make sure we're doing is like those little catches and things. Those are opportunities for disaster. So before we go any further, I'm going to turn the system off, let it work its way to reset. But I don't know if you saw it there, but just even as I turned it off, it wiggled back and forth. We're going to put up safety rails. And in here we have, oh, we can check it here. So what we get real easy and cheap off the little buildings, the ruins, are these durability 3 net blocks. And it's not durability, I'm like, it's friction. It's friction 3 net blocks. And that's what we're looking for, because if we're looking at the regular metal, it's 4. So even going to these cheap and free ones, it's better. And it should keep everything in place. And this low friction block hopefully allows it to stay there. All right, rails are up. They kind of look cool. I have no complaints about that. Test everything, every step. Test. You will regret it. You don't. And we got our button to play with the memory. I'm really happy how the memory is working. I'm excited. I got it to stop at exactly 5. I think that's really exciting. So, nerd stuff. If you're into programming, and if you're into programming by visual code, I don't know what you call that. It's some pretty basic level coding with just ands and ors, but it does work. All right, I do want to get this painted. More lights in here. Cosmetics now are starting to strike me. We put those guardrails up, and I started to get excited. Let's get to the fun part. So, to water, we still have the same situation where we need to make sure that it's hitting on our markers. We've got these sensors that are detecting those, just like we did on the prior tier of watering system before we got this complicated. And what we'll want to do is tie this in to the water spurt, so we're going to need it, and when it's on both sensors. So let's go ahead and tie that in. So I guess I'll put it down, sure, right there. All right, and I'll get some paint. That's what I can do to help make this make sense to even myself as I try to do maintenance on it. So basically, what I want to have happen when we're on both sensors, either one of these, and it's both, I have an and here. So when both of these are hit and the system is on, so we'll want to make sure the on switch is activated. I can add a separate switch for watering later if we want to turn watering on and off, make it more complicated, but let's get this finished. So when all these are activated, then we can activate a squirt to the water cannon. And another, is that the right one? Yeah. And a squirt to the other water cannon. Boom. So there, those should work every time our sensors are activated on either X or Y, and they're both there, they'll fire, and those will go. Now, next thing they need is just good old-fashioned water. We'll run it back here. There we go. So now, in theory, every time in the center of every pad, it should water every crop. And I'm excited. Here's our trial run. The system is off. We're reset to 0. The only thing I'm missing is a good window. Oh, and we're out of water. I'm like, what is happening? So that's another reason we have this. Another reason we have this gate here is to make sure that whenever we draw water, we turn on the pump. And I didn't tie the system to it. So when I turned it on, I also need to make sure we turn on the water pumps. Like that. There we go. And that little guy, he pulls in water fast. So even with the system running, and you can see it kind of goes up and down, it's going to catch up. But for now, I think we're dialed in. I'm ready to try a test. Crossing our fingers. We are, the memory's all reset. We're going to just turn it on. And I'm hearing water. Oh, I've got one watering and the other one not watering. And oh, this one's not set. It's not tied into the trigger. Yeah, one of those things when we redid it. So there we go. Now it's tied to the trigger. And there we go. Instantly, it's right back on track again. This is great. And the first one, which was on trigger, has not missed a single plot. It is proving itself to be as reliable as promised. And there you have it. A fully automated watering system. It tracks to the row, to the target. It does each row up and down twice so that we make sure everything is fully covered. It doesn't waste water. You know, we're not like pumping out more water than we're using, so even a single pump is able to handle both of these really well. And once we get some real big crops in here, we're really going to be stirring up some trouble with the locals, we'll call it. It's working perfectly. That is great. There you have it. A fully automated watering system, all complete with, I'm down to 2. I'm out of concrete. A fully automated watering system complete with memory. It's got a 1-bit generator so we can make sure we're clean on the memory use. Of course, we've created a lot of spaghetti code in the process, but for reasons. It's a smart system. And I look forward to expanding on it in the future. So I thank you very much for watching us build together the watering system. And I appreciate your subscription and your like. And I look forward to seeing you again in the next video. Thank you.